more than 10 years now, the process automation supplier community has been working on new networking technology that would finally allow Ethernet to be extended to field instruments, with power and communications over a single pair of wires and in hazardous areas to boot. In this past spring at the Acoma Pulse Virtual Trade Show, a consortium of suppliers and all the key standards development organizations announced that specifications and chipsets for Ethernet Advanced Physical Layer, or Ethernet-APL, were ready for prime time. But what comes next? Hello, this is Keith Larson, editor of Control Magazine and ControlGlobal.com. Welcome to this Solution Spotlight episode of our Control Amplified podcast, sponsored today by Emerson. With me today to talk about Ethernet-APL and what it means for the future of field communications in the process industries is Paul Sereiko, Director of Marketing and Product Strategy for the FieldComm Group. Welcome, Paul, and a real pleasure to chat with you today.
Well, thanks a lot, Keith. And in addition to my role at FieldComm Group, I've also been very active in the Ethernet-APL marketing committee over the past several years. So, anytime that I get an opportunity to talk about the profound change that I think Ethernet-APL will eventually bring to the process automation business, I'm welcome to do so.
Yes, absolutely. And there was a method of my madness recruiting you to speak at this podcast, obviously. We've both been involved, obviously, in developments on the Ethernet-APL front, you even more so than me. But in a just completed survey of control readers, most of our respondents said they were just somewhat aware of this new technology. Obviously, it's brand new. That's to be understood. Part of the purpose behind this podcast is really bring people up to speed and what the potential is and how that can work on their behalf. I'll have a little bit more on that survey a bit later, but maybe to start things off, maybe you can just review what unique advantages Ethernet-APL brings to field communications. Then we can talk about the survey maybe a little bit more after that.
Yeah, I'll do that. But first, I actually want to say that I was pleased with the percent of people that indicated that they were somewhat aware with Ethernet-APL. We'd asked this question on a survey back in early 2019. And literally over 80% of the respondents were either unaware or had a limited awareness of Ethernet-APL.
Okay.
So I kind of count these results as a win for the hard work that the Ethernet-APL marketing team has been doing over the past several years.
Wow.
So
Progress.
I was excited by the results. So
yeah.
But with regards to your question, I think it's important to realize that for quite some time now, instrument and infrastructure suppliers have really wanted to extend Ethernet networking capabilities to the field level. But, doing this requires a physical layer that meets the demanding needs of process automation. And you'd mentioned a couple of these things in your introduction. Deployment in hazardous areas is certainly one. Yeah. Support for long cable runs is another. And copper is expensive, so a two-wire solution is really something that's needed because that's what they use today. And those two wires have to carry both power and communications. And unfortunately, the technology, and by that I mean the standards and components that would require to implement high-speed Ethernet-APL with these requirements, it just hasn't been available until now. So, so in and of itself, the Ethernet-APL physical layer is unique in that it just meets these installation and deployment requirements for the process automation industry. But probably the most notable additional advantage is speed, which we haven't talked about yet. But Ethernet-APL is a 10 megabit per second standard communications rate. And those are digital transmission speeds that are orders of magnitude faster than kind of precursor process automation physical layers like 4 to 20 milliamp, which is really bound by 1200 or 9600 baud modems and field bus, which is faster but nowhere near 10 megabits per second.
Right. Yeah, no, that makes a lot of sense. And I think one of the things that's interesting about the having Ethernet this layer is the ability to accommodate multiple protocols and do things that are uniquely Ethernet skills compared to our legacy environments in the industrial space. That's for sure.
Yeah.
in that survey that we did of control readers, all these characteristics were really identified as important. And for those of you who get Control Magazine, we'll have some. This is better fodder for graphs and bar charts and things like that. So some of this stuff, you can pick that up in our September issue when that comes out, or come back to the website in September, and you'll be able to see the full survey results in detail. Very great. Faster data rates and hazardous area suitability certainly came out on top. I do think that the fact that Ethernet-APL is protocol independent can get confusing when you talk about accommodating multiple protocols over the same wire. Can you kind of unpack that a little bit and what that means from a practical perspective? I don't think people are used to having, in the context of field instruments, the ability to have different things going on in the same pair of wires.
Yeah, and honestly, that's going to require kind of a mindset change on the part of engineering firms and process automation systems designers and things like that, because we like to say in the Ethernet-APL marketing committee that Ethernet-APL is just a physical layer. It's just that. And so what's happened, in the past, in process automation at least, is that the physical layer and the application layers have been kind of coupled together. Mm-hmm. So, in 4 to 20 milliamp, you've got HART, which is the application layer sitting on top of the 4 to 20 milliamp PHY, and in Foundation Field Bus and in Profibus PA, you have a digital protocol embedded into the Field Bus physical layer. Right. Now, with Ethernet-APL, that metaphor has been kind of blown apart. So the physical layer is actually decoupled from the application layer. And that's, it should be intuitively obvious to anybody that has an IP network deployed in their home, and mm-hmm. You have printers on it and cameras on it and doorbells on it and computers on it and things like that, and all of those devices are using different application protocols, but they're using a common media access and transport protocol, which is IP, Internet Protocol, basically. So, we've decoupled that with Ethernet-APL, and I've got an example that I want to talk about, because I think that this decoupling is going to ultimately enable much flexible and simpler network designs, network infrastructure designs, and eventually new instrumentation and instrument architectures as well. But let's first address the flexible network design topic. Our 2018 Plant of the Year, FieldComm Group has an annual program called the Plant of the Year. Sure. I know you're very familiar with it because you publish a story about it in the FieldComm Group supplement every year in Control. But anyway, our Plant of the Year winner back in 2018 was the Shell Prelude floating liquid natural gas facility located off the coast of Western Australia, well off the coast of Western Australia. Now this plant has 8,000 Foundation Field Bus devices for control, 4,500 HART devices for safety instrumented systems and fire and gas systems, and over 1,000 wireless HART transmitters, I believe, for doing various monitoring and optimization and those types of analytic applications. And then they've got a whole software architecture, analytic software and stuff that runs alongside and on these, on these instruments like ValveLink and other analytic software. So, so to engineer this system, the integrator that needed to do this, they needed to at least deploy wiring and infrastructure for HART, wiring and infrastructure for FF, and Ethernet for the top end of the wireless HART gateways. Right. So you have 3 separate networking infrastructures in the facility, at least. Yeah. Okay. Now, if the facility were instead based on Ethernet-APL, a single network could be deployed, and the engineering firm could then pick kind of the best automation protocol for the various applications implemented in the facility, but it all runs over the same network infrastructure. So maybe you want to use Profinet for motor control, HART IP for basic instrumentation and control, and maybe Ethernet IP for complex analytical instrumentation and the software associated with that.
Mm-hmm.
Now, that's just an example, but you can imagine the flexibility that's being gained by deploying an Ethernet only architecture into that facility.
Yeah. And then,
so that's, yeah, go ahead.
I was going to say, and then there's other types of devices that we haven't really envisioned having part of a camera, let's say, that's what I guess be a TCP/IP type of protocol, and still leverage that same infrastructure.
Yeah, cameras would be a good, a basic video camera is a great example. What about a thermal imaging camera?
Yeah.
There's just think about the various things that are sitting on your home network today.
Yeah.
Or your corporate network, and imagine how an industrial process automation focused implementation or instantiation of them would be. That's now enabled because of the Ethernet-APL physical layer and its ability to be deployed in intrinsically safe hazardous areas. It's a huge game changer. So the other thing I think it's important to realize, though, is that all of this is going to be a journey, and we've just kind of described a gee whiz scenario. So, but in reality, Ethernet-APL, it's going to take time to gain market share. It's a conservative industry, the process automation industry, and, it's kind of incumbent upon standards development organizations like FieldComm Group and suppliers like Emerson to provide a reasonable roadmap for the journey that a user will undertake to adopt the technology. I can't overestimate how important it is to not oversell this at this point in time.
Yeah, that makes a lot of sense.
Mm-hmm.
We also asked our readers to score the relative merits of 7 different value propositions that APL addresses. And the first among relative equals, they were all deemed important, was fast and easy device installation and commissioning. I was surprised to see that rank so highly versus something more oriented on ongoing operations, really focused on the project activities up front. Do you think that's kind of a symptom that people are used to interfacing with their smart transmitters only when they're installing them and commissioning them versus on a regular basis? Or what do you think's going on there?
Yeah, well, I think you brought up a point when you introduced the question that I think is really cool, which is that we mentioned these 7 different value propositions, and all of them were fairly equally, distributed in terms of importance.
Sure.
And I like your term "first among equals." But I think fast and easy device installation and commissioning is kind of the low-hanging fruit feature. Speed is something that's easy to understand, so I'm not really all that surprised by this. And the place where speed is most obvious is when you're installing and commissioning hundreds of instruments. I think about the Prelude facility that we mentioned earlier with tens of thousands of devices, and as diligent as I'm sure the engineering team was in pre-configuring these devices, I'm sure that during startup they found some things that needed to change, and there you are.
It's not like
that takes days.
Yeah. It's not like downloading an app on your smartphone, which is a much bigger file, and we're also used to that happening so quickly in our personal lives.
Exactly. I just got a 5G phone too, and I'm like, wow, this is fantastic. This is the greatest thing since tea and beer.
What can I do next?
Yeah, exactly.
Yeah.
Exactly. So so speed is kind of a low-hanging fruit feature, and using speed to make this, onerous task of commissioning devices much less onerous, and frankly, much less costly and much less labor intensive, and probably much less prone to error is a big benefit. I think there are other speed features that will, speed related features that will become apparent as the industry partners that are part of the Ethernet-APL initiative begin to announcing new devices. And, honestly, one of the things that I'm looking forward to is to see, how device vendors might choose to incorporate, DDs, drivers, application software, FDI device packages, which could bundle all of those things together on their device.
Right.
as opposed to us apart from the device in a in a catalog of drivers. And when you and I, when we buy when we install a new piece of software, a mouse or something, one of the first things the system does is it goes out to see whether there is an updated version of it, and then it installs it and does all of that kind of in the background. And that's something that's enabled by having high speed capabilities. And I think that over time we'll see instrumentation architectures actually change and include more onboard software than they do today. Now, obviously, there's cost issues, there's memory issues, there's a whole host of issues. So I don't think you're going to be buying them, 3 months from now.
Right.
But in time, this is one of the features, one of the benefits, regularly, that are enabled through Ethernet-APL.
So something more like what we experience with a printer nowadays, where you don't have to go to the website and download a driver. You might want to do that from some more advanced features, but usually you plug it in and it handshakes, recognizes, and away you go.
Yeah.
Not like,
and if it needs to update something, it does.
Right. It doesn't even ask.
Yeah.
I did think one of the interesting things too among these value propositions was that was also considered quite important was Ethernet. Because it is Ethernet, it allows those kind of already established cybersecurity models that are established in the Ethernet world to be applied at the device level, which is, as most of us understand, that the older digital protocols don't have that inherent security built in. And yet we also asked about significant barriers, and one of the barriers was also the fact that using Ethernet there opens it up to cybersecurity risk. So can you kind of square that apparent contradiction for our listeners today?
Yeah, I can. I can try. I think that if a given instrument is IP addressable, if that's kind of the given, then it better have great cybersecurity.
Right.
So, again, I think it's the job of the suppliers and the SDOs to evolve the technology and then educate and overcome what's clearly going to be, and rightfully so, hesitation on the part of end users to drop IP addressable devices into their plant. And maybe the first thing they'll do is they'll do it on monitoring applications or optimization applications and stay away from control just because of that hesitancy.
Right.
But it's also incumbent upon the SDOs, the standards development organizations like FieldComm Group, to make sure that we've got our ducks in a row in terms of our specifications. We just released late last year a new version of the HART specification, of which HART IP is a component. And where previously the HART IP portion of the specification said your device shall have security, the new version says it shall have this type of security, and it shall do this, and it shall be able to do this, and we're going to test for all of this and validate that that it's there before we grant you a registration certificate that says your HART IP device is certified. Now, I'd be happy to discuss all of these details and PS key encryption and certificates and all of that sort of stuff, but I don't really understand any of that stuff. So if you want to do a future podcast with Wally Pratt and geek out on HART IP security, I'd be happy to introduce the two of you.
Sure. Yeah, I know Wally well. I think that's better for the bar, I think, than a podcast, or maybe.
Yeah, you're probably right.
For the bar conversation.
You're probably right. Yeah.
But it's good that some people know how to do that. There's no doubt.
Yeah.
I thought another interesting comment that was ranked highly as well was, and is one of the really aspects of Ethernet-APL and what it opens up, is the ability to integrate traditional as well as APL devices. You mentioned that obviously that shell environment where they had a very mixed architecture. With APL, how is it that you can kind of go forward and still accommodate maybe traditional analog devices with the old frequency shift keying?
Yeah. Wow.
into that hardware. Hey, FSK, I actually.
I'm impressed you know that.
Exactly. But then Ethernet-APL devices that also speak hard IP. So there is some commonality there. But then you've really got a third physical layer, as it were, with wireless HART, going over the airwaves around us. So how does that kind of commonality across those three different modalities accommodate a path forward where if you've got all this existing technology, how can you start to incorporate other new technologies over Ethernet-APL in a mixed environment?
Yeah, and this kind of gets to the point where, where we really need to do a good job of describing the journey that an end user will be on if they plan to adopt this technology. And, I went through this a little bit in the early days of wireless HART and ISA 100 when I was involved in an operating company that was actually making products in that space. And, we made some recommendations. There were some pretty strong recommendations about where you should use wireless, where you might not want to use wireless, how you might want to evaluate if you're going to use wireless.
Right.
And I think ultimately the same thing is going to happen here with regards to Ethernet APL. So, if you look at, what the industry would love to do is have everything in the in the plant, including all of your critical control loops, operating under IP addressable, under an IP addressable system. But I think it's going to be a while before the end user community, particularly in areas where, there are hazardous environments, which is the primary target area for Ethernet APL, to make that leap. So it's important to have a strategy that allows for some commonality as a company migrates from a pure 4 to 20 milliamp plus, clip-on in the field monitoring and, diagnostics and configuration and maintenance and stuff to this fully digital solution. And the good news about at least the HART ecosystem is that it's very well known in the industry. So, if you're going to be learning a new networking infrastructure, with Ethernet IP, but it'd be nice to have some familiarity with the application software layer, and that application software layer is more often than not HART in the process automation industry today. So, so the asset management system, the control systems, all the things that you use in all the work processes that you use today in HART need to kind of smoothly migrate over into the HART IP world. And that'll remove a kind of a big barrier to entry for some users, because they won't have to learn, new automation protocols or new techniques. So,
yeah, I think
the single software environment is one of the big things. And I guess I would reference the Ethernet APL live video demo that was done at the ACMA show, and there's a segment where in that video where Emerson showed how in a single control loop they had a 4 to 20 milliamp device and an Ethernet APL device, and from the perspective of the operator or the asset management system, there was no difference. You couldn't, you wouldn't be able to tell one from the other unless you drilled deeper.
Right.
So
that makes a lot of sense. But I think some familiarity with the data models that are part of HART and have been part of HART for 40 years now. If there's some built-in familiarity of how those models are presented, and it's just like it's a semantic model basically, kind of like OPC-UA talks about semantic models as well. The transport, the language is still there, even if you're speaking over a different technology.
Right.
The language,
right? Exactly.
Still the unifying.
Exactly.
Yeah, and speaking of that, I mean, HART has come a long way since it was first introduced back in the 80s. And HART IP includes now an integrated security model, which I think you mentioned before, and that'll help address concerns over increased cybersecurity risk. What other aspects of hard IP over Ethernet can help streamline the process industry's journey into this this brave new world as we journey forward?
Yeah, well, one of the I guess I'll call it a major initiative in process automation right now is being spearheaded by the Namur organization with the Namur open architecture and the associated use cases and requirements for meeting the desires of that architecture.
Mm-hmm.
And much of it is focused not on the core process control systems, but on the monitoring and optimization
Mm-hmm.
systems
Mm-hmm.
that are enabled through digital transformation and IIoT and all of that sort of thing.
That kind of second alternate path for all that other data that's beyond the control. Yeah.
Yeah, and if we've seen the diagrams with the triangle with the wedge attached to it, and in that wedge where you have the plant monitoring and optimization, and then the path upward to the enterprise-wide monitoring and optimization, you end up with a lot of new applications, new analytics, and things like that. But all of that is predicated on having a protocol at the instrument level that is rich in diagnostics and maintenance and configurations capabilities. And HART has always been perceived as a diagnostics and configuration protocol, with 4 to 20 milliamps still being the predominant method of control.
Right.
And but there's a lot of merit to the claim of HART being probably the most built out diagnostics capability, having the most built out diagnostic capabilities of any process automation protocol.
Mm-hmm.
So that means that the underpinnings of providing the data for these NOA use cases and the requirements and all of that sort of thing has been there, and it's been there for decades.
Mm-hmm.
So the challenge is always with HART has always been getting the information out of these 4 to 20 milliamp 1200 baud devices.
Right.
So I think that Ethernet-APL is going to dramatically simplify that. There's not going to be a lot of gateways. There's not going to be a lot of translation of data between different levels of the network, and it's going to simplify things. And what better way to take advantage of that than with the protocol that already has all of the bells and whistles needed for doing advanced diagnostics and analytics and things already built in.
Yeah, that makes perfect sense to me. That's for sure.
Mm-hmm.
Although we do have a ways to go.
Yeah, but I think I want to talk about that. We do have a ways to go a little bit in just a little bit, because you didn't ask a specific question about it, but I think it's really important to realize the workforce changes that are already underway and will continue to be underway in the process automation industry as a younger workforce takes the place of guys that frankly were very familiar with using 4 to 20 milliamp transmitters and things like that. And as that happens, you're going to bring in a workforce that's going to be more thirsty for knowledge and more willing to use these new technologies, and more capable of walking up to an instrument with that may have Bluetooth capability and being able to connect to it and talk to it and and work with it. So I see the Ethernet-APL technology coming out at exactly the right time for the market to transition as we continue this kind of ongoing cycle of retirement and rejuvenation in process automation.
And those people coming into the profession, if they've got any kind of networking training, it's probably on Ethernet. That's probably for sure.
Yeah, exactly. Exactly. Come on, it's our kids, right? It's we tell them how do I get this camera to work?
We ask them, absolutely, no doubt about it.
Exactly. So.
Well, it's going to be an exciting journey, and I think the timing is good, but many issues to be resolved. And we're starting the journey today with this podcast to help spread the word so people can understand better where to contextualize these new products and new architectures that are coming out from the supplier community as we move forward. So Paul, I want to really thank you so much for sharing your insights with us today.
You're very welcome. It's been fun, and I look forward to listening to the output and reading the content in the September issue.
Sounds great. For those of you listening, thanks also for tuning in. Thanks also to Emerson for sponsoring this episode. I'm Keith Larson, and you've been listening to a Control Amplified podcast. Thanks for joining us, and if you've enjoyed this episode, you can subscribe at the iTunes Store or at Google Podcasts. Plus, you can find the full archive of past episodes at controlglobal.com. Signing off until next time. Thanks again, Paul. Really appreciate it.
You're welcome.